EDX Core Pure, complex numbers 3, modulus, argument and loci, multiplying in the modulus argument form. Here we have two complex numbers z1 and z2 which have already been put into the modulus argument form, as you can see, and what we'd like to do is to multiply them together. So we've started off with z1 times z2, and I've rewritten it as r1 r2 times the first bracket times the second bracket. And if we rewrite this again now, r1 r2, and I'm now going to expand the two brackets. So there's cos theta 1, cos theta 2, there's plus I sine theta 1, cos theta 2, there's also plus I cos theta 1, sine theta 2, and at the end there's an I squared sine theta 1 sine theta 2. And I'm just tidying it up a little bit more. R1, R2. So we've got a cos theta 1 cos theta 2. If you look at this final term, it contains an I squared term, which is minus 1. So I'm going to put that term in next because it's real. So that'll be minus 1 sine theta 1 sine theta 2. And now with the remaining two terms in the middle, I'm going to take I out as a common factor. So that's I sine theta 1 cos theta 2 plus cos theta 1 sine theta 2, which is r1 r2. Now you may or may not have come across your compound angle formulae. Don't worry if you haven't, they will be in your formula book and explained at a later stage. So this piece here, cos theta 1 cos theta 2 minus sine theta 1 sine theta 2, can be written as the cosine of theta 1 plus theta 2 plus I, and this bracket here, sine theta 1 cos theta 2 plus cos theta 1 sine theta 2, can be written as the sine of theta 1 plus theta 2. So we've now got the answer in this nice neat form, and what we notice about the answer is the modulus of this answer, z1, z2, is simply the product of the modulus of z1 and the modulus of z2. And the argument of the answer, the argument of z1, z2, which we can see here and here, is the sum of the arguments. So it's the argument of z1 plus the argument of z2. So the modulus of a product is the product of the moduli, and the argument of a product is the sum of the arguments. These results allow us to quickly multiply numbers in modulus argument form. For example, here we've got z1 and z2 in modulus argument form, and we're looking for z1, z2. So a quick way of doing this now is to think about the modulus of z1, z2. So I'm going to do them separately just so you can see the process. The modulus of z1, z2 is simply the product of their individual moduli. So that's 6 times 4 is 24. I've got to do the argument again. I'm going to do it separately. The argument of the answer, the argument of z1, z2, should be the sum of their individual arguments. So the argument should be 5 pi by 6 plus minus pi by 4. So the argument of the answer is 7 pi by 12. So now we have the modulus of the answer and the argument of the answer. We can write down Z1, Z2 without any further calculation. It must be 24 bracket the cos of the argument plus I sine the argument. And it's always good practice at this stage to check that the argument is between minus pi and plus pi. Make sure it's a principal argument. And there you can see the full method. Here in example 2, again, we've been given Z1 and Z2 in modulus argument form, and we're looking to multiply them together. This time I'm going to do it in one calculation. Now we know the process. So Z1, Z2 is what I'm looking for. So to find the modulus, I multiply the moduli together, so that's 2 times 3. Then it's the cosine of, we need to add the arguments together. So that's 5 pi by 8 plus 7 pi by 8 plus I sine, and again to get the argument we add the individual arguments together. 5 pi by 8 plus 7 pi by 8. So tidying this up, 6 cos 12 pi by 8 plus I sine 12 pi by 8. There's a couple of things we need to do now. The first thing, fairly obviously, is to just simplify these arguments down. So that's 3 pi by 2. And obviously the other one will be 3 pi by 2 as well. But more importantly, the argument we've got at the moment is not a principal argument. Okay, so at the moment we're quoting 3 pi by 12. So if I draw a little diagram, at the moment we're quoting that argument which is outside the principal range. We need to quote this angle here, and we do that by going backwards 2 pi. We need to take off 2 pi from the argument. So the correct answer for this is Z1 Z2 equals 6 cos minus pi by 2. So you can see how we've taken off the 2 pi there, plus I sine minus pi by 2. Okay, so you can see the method explained clearly there. If in doubt, it's worth doing a quick sketch and check your angle is between minus pi and plus pi. There's a link here to a GeoGebra file which shows the multiplication of complex numbers, and we're now going to have a look at a similar file to show how it works. So here we can see the GeoGebra file, and we've got complex number Z1, which is 3 plus 3i, which you can see on the diagram, and Z2, which is 1 plus 2i. And at the moment, the answer, which is the green complex number, the length of that answer is the modulus of Z1 plus the modulus of Z times the modulus of Z2, and the direction of that answer is the argument of Z2 plus the argument of Z1, so it's the red angle plus the blue angle to create the green angle. Now if I change Z2, you'll see two things happening. If I make it shorter, the length of the answer gets shorter, the modulus of the answer, but perhaps more significantly, if I make its direction bigger, the direction of the answer gets bigger. So the direction of the answer, which is the green one, is the direction of Z1 plus the direction of Z2. And you'll see the same if I move Z1 So the direction of the answer, the argument of the answer, is the argument of Z1 plus the argument of Z2. In the next session, we're going to be dividing complex numbers in modulus argument form.